Jonathan Sayago, and the long title of his thesis is Electrolyte-gated organic transistors, making use of room temperature ionic liquids as grading media. Advised by the Italian triumvirate Clara Santato, Francesca Suavi, and Fabio Cicoria. So please turn your paper and do not write anything on that one.
Hi. In order to introduce my research topic, I will talk about sports. And in particular, there is one sport in which we can compete against computers, and we don't stand a chance. There is an IBM computer designed in the late 90s that beat the best chess player of all times, and since then we cannot recover. But let's be honest, there is a lot of human attributes that a computer or electronics will never have unless we change the electronic materials that we use to make them. They will never be flexible. They will never smell or taste like we do. So our research is based on incorporating new electronic materials and based on organic materials based on carbon backbone, like we see the molecules on the left part of my slide. And this is a reality now. We can Google great prototypes, flexible electronics, and we will see amazing things coming up. However, still electrons diffuse or are driven very slowly through these materials. This results in high operating voltage. Another property of organic materials is that they can conduct simultaneously electrons and ions. So we want to exploit this ionic electronic coupling to reduce the operation voltage. This is the essence of life. We see this every time in our body or in many living systems. So how we do it in particular, I will need to explain a transistor, which is the key component of electronic devices. 3 electrode component. We have the drain source where current flows, a dielectric, and a gate electrode to modulate the current. We replace the dielectric with an electrolyte medium, and this way we achieve the electronic ionic coupling. When we apply a gate voltage, ions diffuse to the polymer matrix and modulate the conductivity. We have tested different electrolytes to investigate the effect of different ions on the transistor performance. We have achieved sub-1 voltage operation, which is among the most performant ever reported. And finally, I want to say that we have also demonstrated that we can use these devices to store energy at the same time, so to make multifunctional devices. We call it the transcap, transistor supercapacitor. So just to end, I would like to invite you to visit our webpage or write me an email if you have any question about my research. Thank you very much.